Hey there, Blake here. I was going to do a quick video and show you guys how my dual-linked yoke functions. Give you a quick tour of a project I've been working on for the better part of 2 years. Most of it's all handmade except for the yokes and the chart holder and a couple of other parts. Everything else I've done on my own. So, show you guys some of the details here. Now, how about this? I'll pan back and show you what happens when you move everything. So you have both these yokes, they're linked via cable system. And the cable system starts up here at top. And I have this pulley that has 2 slits, and the cable runs down each side. And the cables are offset by about, I think, a 1/2 inch or 3/8. But then the motion of the cable, which is tied to the pulley, it's anchored in there with a couple set screws, runs down the inside of this tube. And this is just PVC. Underneath there's a square steel tube frame that I welded up. So the tube is just for looks. It doesn't have any structure or anything in it. But the 2 cables run down all the way down the tube and then come out at the bottom. And you can see one right here. The other one's right there. And then they go through this pulley system, and you can see they're offset by the same, like, 1/2 inch or 3/8. And it runs along the bottom section of the dual yoke. And then you come to this linkage right here, which I'm going to come back to this, but this has to do with the forces on the yoke. It's kind of an elaborate setup. That's probably a little bit overkill, but anyways, then they continue back up, does the same motion, comes back up this yoke. Try and not get you guys too dizzy here. This one has the cover on it, but it's the exact same mechanism on the inside here, and that's how they're linked. As far as motion goes and getting the motion captured, there's a pulley right here, and I can't remember how many tooth it is, but this one is connected to a lower pulley underneath here, which is almost impossible to see. It's a gold color right here. But this is a smaller tooth pulley, but I figured out the ratio so that I use the full 270-degree travel of the pot. It's a Bourne's potentiometer. I'm not sure exactly which one, but it works pretty well. And it's attached to some shielded cable, which also runs down the length of the tube and back out to a DB9 connector. So, to come back over here and kind of show you guys how this thing works again. Both these yokes are linked, and I was having problems with getting the forces just right, because if originally I just had a very small spring, and I'll show you guys where it is, back up here in the center. Wow, that's almost impossible to see. Anyway, there's a collar on the shaft right here, and underneath there's a spring, and you can kind of see it right back there. So there's a spring back here, and it's essentially just a really short 3-inch spring. It just holds that shaft straight down, so when you turn the wheel, the shaft that shaft collar gets pulled to one side or the other, and it extends the spring a very small amount. But anyways, the force wasn't enough to generate anything that felt like it would be real. I've never felt a real one, but it kind of felt like I was driving on super power steering. So anyways, to fix that, I developed this mechanism, which essentially just grabs the motion of the cables. Switch hands here. And so you get this linear kind of back and forth motion, and I took that, and then you go to kind of this bell crank here via some push rods, and then that comes back to this guy, which all these are is just PVC, and then there's a 3/8 inch spring on the inside of either one of these guys, and it's preloaded. So I have the spring stretched like, I think, about 1 inch or so in there, so that way as soon as you start to put any force on it, you're already fighting a good amount of force inside the spring. It's not like just starting from neutral, I guess, with the spring. It's already pre-stretched a certain amount, so that gives you a good amount of force, a nice crisp breakaway from center point. Always returns back to center. It has a nice crisp feel, and then always comes back and stays in one spot. So can see with this guy, it's kind of a crazy mechanism, but anyways, in order to get all the slop out of it and make it to where it would actually work, I kind of had to design all this up in SolidWorks and make sure all my clearances and stuff would work. But anyways, essentially these are just preloaded springs on either side, and it just gives you a nice force field to the yoke. So I need to do the same thing for the elevation motion back and forth, but I'll work on that later. So there you have it. That's my dual yoke setup. It's based on a Learjet 45, which is the rest of that jet still being designed up in SolidWorks, but hopefully there will be more videos to come. Thanks for watching.